All right, welcome to Class Bridge, a bridge to clarity. So now in this video, I'll be explaining the proof of the triangular inequality, which is the third property of the norm space. So it is going to be as simple as ever. So now you need to understand something, that a norm can be expressed in this form. And also, this is what we are asked to prove, and it is called the triangular inequality. So now, another thing I want you to know is that when you have something like this, you call it the inner product, we call it the inner product of x and y. Now, quickly, by the definition of norm, you agree with me that this is the same thing as the square root of x plus y, comma, x plus y. Do not forget, I'm talking about this. From the definition of norm, this is equal to this. Now, if that is the case, square both sides, and you have this, x plus y squared, that's the norm of x plus y squared, which is the same thing as x plus y, comma, x plus y. Now, let's expand the right-hand side and see what we get. So expanding the right-hand side, you have, don't forget, if you have not seen the videos that I made before this, try as much as possible to go see the videos. Now, the expansion is done this way. This x comma this x plus this x comma this y, and this y here comma the x over there plus y comma y. So now let's put this together. We have x comma x plus, don't forget, one of the inner product properties, the symmetric property, says that x comma y is the same thing as y comma x. And if that should be the case, it means that we have 2 into x comma y, that's the absolute value, plus y comma y. Please, I want you to be attentive. Now, there's a proof before this proof that made us to understand that if you do something like this, is the same thing as, is less than or equal to the absolute value of. So before now, I have a proof on the Cauchy-Schwarz inequality that proves that this guy here is less than or equals to the norm of x dot the norm of y. So we're going to be using that here now. Since this is true, then you agree with me that combining this and this, I have this guy. I have this guy. If I combine these two, based on this theorem that has been proved. So now, don't forget that this is the same thing as norm squared. From this part, from the definition given to us, they said the norm of x is the same thing as the square root of norm x, the square root of inner product of x with itself. So if you bring this square root to the left-hand side, it means the square of norm x is the same thing as x comma x, right? So if that is the case, then it is safe to say that this part is also norm x squared plus 2. Now, don't forget this part, which is norm x, norm y, plus this will also give us norm y squared. I hope you are following me. So now, let me write out this part carefully so we'll be on the same page. This is what our result is like. Okay, so if you are still following, now, if you look at this idea, it looks like a perfect square. Look at it. If you have a square plus 2ab plus b squared, if you factorize this, you see that you have a plus b squared it is the expansion of a plus b squared that gives this. The same thing if you have x squared plus 2xy plus y squared. You realize that is the factorization of, is the expansion of this that gives you this. So the same thing goes here. Let's assume this is our a squared, this is our b squared, this is our 2ab. Then it simply means that this is also the same thing as the expansion of this, right? So when you have this, it means the left hand side is equal to the right hand side. So now there's a mistake we made that I want us to correct. Anytime you are using this, don't forget we have a less than or equal to here. So this is supposed to be a less than or equal to because of this that we introduced. Why? Because this is actually less than or equal to this. So whatever we are writing should be considered as well. So the same thing goes here. So this should be less than or equal to, and this also should be less than or equal to. Sorry for that. So now, when you square both sides, the square root of both sides will go away. And you'll be left with x plus y, that is the norm of x plus y, less than or equal to the norm of x plus the norm of y. And the triangular inequality has just been proved. So if you find this video helpful, please subscribe to this channel for more interesting videos.